Damn. Okay, there's this integral which looks pretty complicated because like, this is integral from 0 to 1 of ln square x and then log of x divided by 1 minus x dx, right? So like there's a lot of log and then like also like nested log. So yeah, that definitely makes it scary, right? But it turns out like this just looks scary, but I mean if you know the formula that I have been using in a couple of my previous videos, then you will actually notice like how this integral is actually formed, right? Okay, also so in a couple of my previous videos I've been using this formula, and then again this integral is also like made from that formula, and let's see how we can solve this integral. Okay, so this integral like which I have already derived is negative 1 to the power n gamma of n plus 1 by a ln plus 1 of a, right? I can put the video in the description if you want, right? Okay, now notice that if I partial differentiate both sides uh, with respect to n, right, then let's see what happens. So in this side this will be integral from 0 to 1 and then ln of x to the power n, right, times we will have ln of ln x, right? Because for a to the power n, it's a to the power n times log a, right? By 1 minus ax dx. And on the other side, this will be for like we have to use product rule. First of all, negative 1 to the power n times log minus 1, and the rest of them as it is, right? Divided by a plus. Now the derivative of the second term. So this is gamma prime of n plus 1, and the rest of the things as it is, divided by a, and then over here let me write it as partial derivative with respect to n of li n plus 1 of a, because if I write li n plus 1 prime, like that usually means derivative with respect to a, so that's why I'm writing in this way. Okay, so now for our case we have n as 2, right? We have n as 2, right? And then a as 1, right? So let's find this value for n as 2 and a as 1. So this becomes okay, what does this become? Okay, negative 1 to the power 2, so this is just positive 1, right? And then log of minus 1 is I pi, we'll take the principal value, and then gamma of 3, and then li 3 of 1, right? Plus, and this is again negative 1 square, is just negative 1 square is just 1, and then gamma prime of 3, li 3 of 1, and then negative 1 square is just 1, and then gamma of 3, and then okay, what will basically happen is we will have a partial derivative with respect to n of li n plus 1 of a, and then we will evaluate it equals to 1 and n equals to 2, right? Okay, so okay, to find the partial derivative of the li function, let's see how we can actually go. We know that li, okay, yeah, first of all let's find that and then we'll substitute all the values. We know that li n plus 1 of a is basically the sum from k equals to 1 to infinity of a to the power k by k to the power n plus 1, right? Now if we differentiate this with respect to n, right, what will happen is you will now have sum from k equals to 1 to infinity of a to the power k over here, okay, k to the power n plus 1 times log of 1 by k, right? Yeah, yeah. And so now if you substitute a as 1 and um n as 2, what we will have basically have is partial with respect to n of li uh okay, n plus 1 a at n equals to 2, a equals to 1. So this will be now from k equals to 1 to infinity 1 by k cube and then basically negative ln of k, right? So yeah, now you can see that this will also basically be the zeta prime of 3, right? You can see that basically because zeta prime has negative ln of k and by k to the power n, and here n is 3, so it's the zeta prime of 3. And value of zeta prime of 3 is well known, it's in Wikipedia, right? Now, so yeah, this value is now known. This value is just zeta prime of 3, right? And okay, gamma of 3 can be found out. Also now for gamma prime of 3, and this is, we know that's zeta of 3 because li n of 1 is zeta of n. This is also zeta of 3. Gamma of 3 is 2. Gamma of 3 is just 2. It's 2 factorial, right? And now for like gamma prime of 3, we know that gamma prime of n is gamma n, digamma n, right? And then gamma of 3 is just 2 factorial, which is 2, and digamma of 3. Now for this you can use the formula gamma of n plus 1 is equals negative of Euler-Masoni constant plus nth harmonic number, right? So okay, so now where harmonic number is basically 1 plus 1 by 2 up to 1 by n, right? Now in this case, for 3, it's 2 plus 1, right? So it's negative gamma plus at sub 2 is 1 plus 1 over 2. So this is negative gamma plus 3 over 2, right? So this becomes 2 times negative gamma plus 3 over 2. So that means this is 3 minus 2 gamma. So I'm saying this gamma, but this is actually Euler-Masoni constant, right? So over here, this becomes 3 minus 2 times Euler-Masoni constant. So now if we just substitute all the values that we have arrived at, and Euler-Masoni constant is basically some 0.577, something like this. And all the values you can find on internet. Yeah. So this becomes I pi 2I pi zeta 3 plus 3 minus 2 gamma zeta of 3 plus 2 zeta prime of 3, right? And that's basically the answer, and this answer was verified through Wolfram alpha, right? So let us take the answer: 2 pi I zeta of 3 plus 3 minus 2 Euler-Masoni constant zeta of 3 plus 2 zeta prime of 3. Yeah, that's the answer. And like you can, if you want like some numerical answer, you can either use your Wolfram alpha, or you can find all of these like constants in Wikipedia, right? You can just Google them and then substitute and then get an answer. Okay, that was it, guys. And here, like, yeah, what I wanted to show was like, sure, sometimes like you can just you can just make complex integrals by like partial differentiation. So yeah, just look out for them. Sometimes it could be helpful, right? Just like how such a complex integral was found from a easier formula, right? So yeah, and you can verify this from Wolfram alpha, and I hope you liked the video. Thanks for watching, and I'll look forward to seeing you in the upcoming videos too.